Today's lesson's on domain, range, end behavior for the square root function. Let's look at this function, square root of x minus 5 plus 3. We want the domain, range, and end behavior. So the first thing we're going to do is, let's graph it. Square root of x, subtract 5, plus 3. Notice here we're going to have a horizontal shift right 5 and a vertical shift of 3 units. First thing I want to do is label that starting point. It's an ordered pair, it's 5, 3. So my domain, leftmost point is 5. This thing, the graph keeps going to the right forever to infinity. Range. Lowest point on the graph is 3. And the graph keeps going up to infinity. Now let's do my end behavior. As x approaches my leftmost point, that's the ordered pair, so I want this ordered pair that I have to match up. As x approaches 5, f of x approaches 3. Now I'm going to use my other x value, which is infinity, and my other y value, which is infinity. So as x approaches infinity, f of x approaches infinity. Okay, let's take a look at our next problem. Got negative square root of x plus 3 subtract 4. First thing we're going to do is graph it. We're going to have a reflection over the y-axis. Horizontal shift left 3 units and a vertical shift down 4 units. First thing I'm going to do is label my starting point, which you notice here is negative 3, negative 4. My leftmost point in the domain is negative 3. Graph keeps going right forever to infinity. So we're going to do negative 4 because that's where my starting point is, and the graph goes down forever to negative infinity. But notice here we have negative 4 is greater than negative infinity, so we like to always start at smallest number, so we need to switch these around, negative infinity to negative 4. My starting point is my leftmost point, so I'm going to match these two ordered pair up. As x approaches negative 3, f of x approaches negative 4. Now I'm going to use our other x value, which is infinity, with my other y value, which is negative infinity. So as x approaches infinity, f of x approaches negative infinity. All right, let's look at a third problem. Square root of negative x plus 2. We're going to have a reflection. We got b here, reflection over the y-axis, and a vertical shift up 2 because we have d. Let's graph it first. We want to label our starting point. Starting point here is 0, 2. Leftmost point. This graph keeps going forever left, so negative infinity. Furthest right it goes is 0. So we say from negative infinity to 0. Range. Lowest point is 2. Goes up forever to infinity. So from 2 to infinity. Now my ordered pair, or my starting point, is on the furthest right. So I'm going to take that ordered pair, put it in the bottom, 0, 2. As x approaches 0, f of x approaches 2. I'm going to use my other x value, negative infinity, and f of x, my other y value, infinity. So as x approaches negative infinity, f of x approaches infinity. Now let's look at another problem. We have negative square root of negative 3x plus 6. So we have an a, that's going to be a reflection over the x-axis. We have b being negative, so we got a reflection over the y-axis. We have b also being 3, which is a stretch by a factor of 3, and we have d, so we have a vertical shift up 6 units. Let's look at the graph. First thing I'm going to do is plot my starting point at 0, 6. So domain goes left forever, so negative infinity. 2, furthest right is 0. So from negative infinity to 0. Range goes down forever. Remember, negative infinity is my smallest point. Smallest value. Negative infinity. Highest value is 6. From negative infinity to 6. My starting point is on the right-hand side. So as x approaches 0, f of x approaches 6. I'm going to use my other two values, x and y. Both of them are negative infinity. So as x approaches negative infinity, y approaches negative infinity. Okay, I have a few problems for you to try. Try these. State the domain, range, and end behavior. Remember, you're probably going to have to graph them before you can do the domain, range, and end behavior. 2.